So this is lesson 2.7. This is a picture of the National Air and Space Museum at the Smithsonian in Washington, D.C. This is Algebra 2.7. And the question is how far is it to the museum? And if we're talking about algebraic expressions, it's easier to evaluate them when we simplify them. And so we're going to be talking about, and we've already talked about in 2 other lessons, using the distributive property to simplify an algebraic expression. And we could do that in this lesson a little bit later to figure out the distance to the National Air and Space Museum. So in a term that is the product of a number and a variable, the number is called the coefficient of the variable. And so you can see in my little diagram here, we have the coefficient, which is 6. We have the little 3, which is the exponent, and x is the variable. And we would say, in this case, that the 6 is the coefficient of x to the 3rd power. So like terms in an expression are going to have the same variable raised to the same power. So 8x and 3x are like terms. However, if I had x squared and x, those are not like terms. They have the same variable, but they're not to the same power. So let's talk about how we identify like terms if you have an expression. And so let's say we have negative x squared plus 5x minus 4 minus 3x plus 2. And so the first thing we would do is begin rewriting the expression as a sum. So if I rewrite the expression in red to be a sum, I would have negative x squared plus 5x plus negative 4 plus negative 3x plus 2. And you can see that we made the changes in these areas so that everything is, we're adding, and then with the negatives associated with the proper numbers. Okay, now we can look here and see that 5x and 3x, negative 3x, are like terms. We can also see that, I'm trying to get a different color here, that negative 4 and 2 are like terms. Again, we're not looking at the negative or positives, we're just looking at the terms here. So let's see if we can work out some examples. So in this example, we have negative 5x squared minus x plus 8 plus 6x minus 10. And so our like terms are going to be the 5x squared, I didn't circle that very well, and the x. And we will have the 8 and the 10 would be like terms. So let's try another one. So you can see here in this example that I wrote here, where the like terms are in the second example and which ones are not. So simplified expressions. The distributive property allows you to combine like terms by adding their coefficients. So an expression is simplified if it has no grouping symbols and if all the like terms have been combined. So we can combine like terms, and the first thing we're going to do is simplify the expression. Here we have 8x plus 3x. We're going to use the distributive property to rewrite the equation. So now we have 8 plus 3 times x, and that will give us 11x. So we added the coefficients here, and we use the distributive property. So we have 2y2 plus 7y squared minus y squared plus 2. And you can see I circled the y squared. Something's wrong with my thing. It's like showing it's not recording and then it's recording. So if I've said this 3 times, sorry. You can see here I added the coefficient 1. So hopefully you got that by now. Next, I take my terms that are like here. We have this one, and this one. I distribute them, so I have 2 plus 7 minus 1, and then y squared plus 2, so I use the distributive property. And then I add my coefficients, which is going to be 9 minus 1, and so I'm going to get 8y squared plus 2. Okay, now we're going to simplify expressions with grouping symbols. The expression here that we need to simplify is 8 minus 2 times x plus 4. We're going to use the distributive property and to rewrite this equation. So we're going to have 8 minus 2x plus negative 2 times 4. So now we can multiply this out. And so when I do that, I get, when I multiply it out, I get 8 minus 2x minus 8. I then group like terms, so I would have negative 2x plus 8 minus 8, and then that simply leaves me with negative 2x when I combine my terms. So let's look at another example. 2 times x plus 3 times 5 minus x. I use the distributive property, and I have 2x plus 2 times 3 plus 3 times 5 plus 3 times negative x. I then can multiply out, so I would have 2x, 2 times 3 is 6, plus 3 times 5 is 15, plus 3 times negative x is going to leave me with negative 3x. I then can regroup, so I'd have 2x minus 3x plus 6 plus 15. I then end up with negative 1x, which we can just rewrite to negative x plus 21. And so the 4 steps that we've done now repeatedly is use the distributive property, multiply, group like terms, combine like terms. So that's how you would simplify expressions with grouping symbols. So let's do a couple examples. 5x minus 3x, well that one's pretty easy, that's just 3x. 8m minus m minus 8m minus m minus 3m plus 5, you end up with 4m plus 5. Negative x squared plus 5x, these cancel each other out, you just end up with 5x. in this next example, we have 3 times y plus 2 minus 4y. I can distribute that out. So that's 3y plus 3 times 2 minus 4y. I can regroup like terms. So 3y plus negative 4y plus 6. I'm going to end up with 1y, which is we don't need the 1, plus 6. Next example is 9x minus 4 times 2x minus 1. I can regroup that, multiply it out, so I'd get 9x plus negative 8x plus 4. End up with 1x plus 4, and drop the 1, that's x plus 4. In this example, you have negative z plus 2 minus 2 times 1 minus z. We can rewrite this, so regroup them, redistribute them. We have negative z when we multiply this out, and we'll end up with negative 2 here. We keep the plus sign. Put a plus sign here, and then we multiply this out. Negative 2 times 1, it's negative 2, plus negative 2z when we multiply those two together. We continue working with our expression, and we end up with negative 2 plus 2z. Over here we can have plus negative 2 and negative 2. That was negative z here, sorry. So we put the like expressions together. Negative 2 plus negative 1z, we're going to end up with just a z. And then negative 2 times negative 2 is going to end up with 4, and so our final is z minus 4. I just realized here that I made an error, which is something that is easy to do, and everybody does it, but it is something to keep your mind at. If I can get the eraser here. Okay, so I want to go back now that I've done this, and this part was right, but this right here was misleading. So it should be negative z plus 2z, because we had two negatives, and so we're going to end up with a positive. So then we have basically negative 1z plus 2z equals 1z. We don't need the 1z, and we end up with the z there. Sorry about that. So now we're going to go back to the National Air and Space Museum and do a problem. So what we're going to do is to simplify a function, which is what I wrote here. And so if you were given a problem, let's say you have 50 minutes to get to the National Air and Space Museum. And if, like my son who lives in D.C., oftentimes, because people just don't have cars in D.C., you have to like walk to the subway station and then catch a bus and then catch subway. You have to really put together a way to get something, because the bus stops at one place, but it could be 15 minutes from where you need to go, or the subway may stop at one place and then you got to walk to a bus stop. So getting somewhere can be difficult. Not in Kansas, we would say, how long would you take to get in your car and go to your destination, but not in a big place. So we have you have 50 minutes. We're going to look at the time. The t is t minutes that you're going to ride the subway at a speed of 0.05 miles per hour. And then the rest of the time is going to be spent walking 0.5 miles per minute. Both of them are miles per minute, sorry. I had, this is miles per minute here. I wrote hour. That's an M. Miles per minute. Okay. Now, where do you start? This is kind of complex. So the first thing you want to know is, what information do we know already, and how can we put this into a formula? Over here, we can write out what's our verbal model, as we list the things that how we're going to label the different parts of the function, and then down at the very bottom we'll put it into an algebraic model. So up here we're going to have distance is going to equal the subway speed. I abbreviated because I'm not going to have enough room on here. Then it's times multiplied by the time riding. So subway speed times the time walking plus the walking speed times the time spent walking, and that would give us what we need. So we need to start labeling our component. So distance is going to be D. So D will be for distance. Subway speed is going to, we'll have that. I don't really have an abbreviation for that. The time riding, let me do this differently. Hang on. Let me erase this because this is going to be confusing. So subway speed, I'll just use SS. Time riding will be T, and that'll, if we're looking at it in a book or something, it would be like an italics T. We'll have the walking speed, and then we will have another T here, but it's going to have a different, so let's go fill in what we have here. So distance, D is going to equal the rest of this. Subway speed was 0.5. The time riding, let's see, we don't know that T, plus, let's see, we need equals, oh wait a minute, hang on. Alright, so what we end up with, and that's this part right here, when I put it all down, we have D, which is going to be distance, is the number that it gave us early. Subway speed is 0.5, it's going to be times T, plus 0.05 times the 50 minutes minus T, because it said you had 50 minutes to get there. Okay, so I rewrote it like what I had on the previous screen. Here's the, so we wrote the function, that's what this is right here. Now I can use the distributive property to rearrange my for my expression, and we can just carry this down 0.05t, but here we can multiply out the 0.05 times 50, so that's what we get here, minus, and we still leave, this one stays the same because we haven't done anything. Now we're going to multiply. So we've used a distributive property and we've multiplied here. So we've done two things. Now we can combine like terms. So we would have 0.05t so then we combine like terms, so we get 0.5t minus that's 0.05t. Left out my 0 there. Plus 2.5, and we end up with, as a result of this, we end up with 0.45t plus 2.5. And so the distance, the total distance that you're going to travel, so our formula now that we've worked it out is D, that's an equal sign. We come up with 0.45t plus 2.5t, where t equals anything between 0 to 50. So if we were talking about the total distance you travel, that's given in this formula, the d equals 0.45t plus 2.5, and we would say that t represents anything from 0 to 50 minutes. So defined, then the next step would be to find the total distance and we will use the function, hang on, function of t in this case is going to equal 40. So we're making t 40. First thing I do is write the simplified function that we already determined. Then I rewrite it to fill in the function. So t is going to be 40, which was given, plus the 2.5. Now we're going to multiply and add. When we do that, we're going to end up with an answer of 20.5. And we could summarize or estimate that it's 21 miles approximately to the museum. So let's try another problem in trying to simplify a function. Let's say it takes you 45 minutes to get to school. You're going to spend t minutes riding the bus at a rate of 0.4 miles per minute. The rest of the time you're going to walk at a rate of 0.06 miles per minute. So we have to do the same thing before. We write out our equations. So d is going to equal 0.4t. That doesn't look like a 4. Okay, that's the t. Plus this part, 0.6. We already know the 45 minutes minus t. And then we can continue on that one, solving that one. So I rewrote it up here on a new screen so I'd have more room. Again, distance equals 0.04 times t plus 0.06 times the 45 minutes that it was given to us minus t. I used the distributive property to multiply out this part. So I distributed this part out. Now I can multiply, and I will have 0.4t. Oh, that's a t, not an f. Sorry. Minus 6t plus 2.7. And you can note that I changed the orders of these two so that I could get my like terms together. And then I can, with my like terms combined, I can now add those together and get, or subtract it, 0.30. Why do I keep writing a t for an f? Okay, 0 plus 27. Now I have my function, and that's what it's asking. It's all it's asking you to do in this example. Let's try another example. So using the equation that we had before, what we just figured out, we can ask now, if you ride the bus 30 minutes, how far away is your school? So we're just going to plug in the time here into the t from the formula that we just figured out. So once you figure out the function, all you have to do is plug in the number. And then we end up with d equals 34 times 30 minutes plus 2.7. The answer is going to be 12.9 miles, or we can sort of round up and say it's approximately 13 miles. in your book on page 109, example 4, it shows you how to simplify a function and go all the way through like we did to set it up, and then to be able to go back and then get the exact miles afterwards. So if you're doing the problems in the lesson and you're stuck, go over to 109 example 4 where it shows you how to write out the formula that I just taught you. For your assignment, before I get into it, you're going to do the same thing with functions, but you're going to do it using one example, the distance with time with a freight train, packing boxes, and another one using the cost of jeans and sales tax. So you'll have some of those problems just like we did here. So your assignment will be, just want to write on here what it is, pages 110 through 112. You have exercises 19, 20, 27 through 29, 36 through 38, 43 through 44, 53 to 60, 64 to 66, 71, 72, 79, 78. Also, so what I have given you right here today, that's what's due today. Tomorrow, on day 2, next day after you finish that other assignment, on pages 119 to 120, I want you to do inductive reasoning lesson. I want you to read the lesson on your own and do the problems 1 and 2, again, that were on page 119, and then exercises 1 through 7 on page 120, and then jump to page 127 and do the problems 1 through 5. Then you're going to start on the chapter summary and review and do problems 1 through 44, and I'm thinking that the test will be on Thursday, so you need to be through with all of this by Thursday. If for some reason you need to take it home, let me know so that we can be ready to do it, take the test on Thursday. Okay? Go forth.